All right, so I'll continue to talk about the access control inside of our classes. Public and private are the new keywords that we use, and I guess we can just follow with some of these slides to take a look at the examples. So when you declare a class, everything is private by default, but then anything that you want to be able to to want the client of your class or the user who's going to be instantiating this class, if you want to give them some ways to work with your classes, you need to declare those pieces public, right? So access control rules, simply member functions can access any other members. Okay, so right now in this class point, I have some functions. For example, adjust. It's a public function. Those member variables that I have are being declared private,
So
right?
those member variables, you would have to, the class would have to receive those two things when you create it, or they would never get value.
They currently, currently in our current state of affairs right here, they contain garbage because I never initialized them. I never gave them any meaningful values. Well, you know what?
When you call it to create one,
I will.
you would have to pass it.
It's a very good point. You know what? Let me do this. Let me close this entire thing and create a brand new project. Just brand new project, and just run this little demo with just another console application. We'll say access control, right? So we create this one, access control, and then we can quickly experiment with this. What I'm going to do is, obviously I need my main function. Okay, and I guess I will create a header file, C++ header file. We'll call it point, since we have those demo point.h. Add that, and then add another new item, which is another C++ file, and we'll call it point .cpp. Add that. Naturally, point.cpp should be including let me just make it right. Okay, including point.h. That's just a very natural thing to do. So is the main.cpp probably also wants to include that, right? So now in the second demonstration of point, clearly I need to do my header guards here, if not defined, but I'll do it later on. Let's just get through the material first. So I'll say to do header guards, right? I have to add them later on, which we should be doing in every single header file that we create or deal with. So going to the point that Mike makes here, we have this class. We name it point. It's kind of overused so far, but that's okay. right now we have this class name point, right? We have to use the semicolon at the end of the class declaration. And we have int x and we have int y, and those two are private. And then let me say that I have a public, so we can public label here. We can also say those are data variables, actually member variables. But those will be our, I guess, public operations, right? So all kind of operations. One of the operations is to perhaps I'll name it set. Okay, so the set which I will now define in point.cpp, and I'm going to say okay. There is a void point set which should take apparently a couple of integers, xx and int yy. I guess those would be possible names for the parameters, right? And in this function I will make sure that my x and y receive their values, right? So we have those two, so this is x and yy, 2 lines, very simple. Make sure we set the coordinates. Now, so moving, any questions about this so far? So I declared a couple of variables, member, what is that? So operations is set. Then so set is very simple. But the point of that slide where we were talking about access control rules is this. This is a public function set, normal member function of our class. And it has absolutely no reason to worry about the access to x and y. It can access. This can be made a public function, it can be a private function, it doesn't matter, right? This, as long as you have a member function and you have member variables of any kind, whether private or public, they're completely accessible by member variables, by member functions, right? So all member functions have normal access to all member variables, regardless whether public or private, inside our class. Now, at the same time, outside, but recall that we're doing this using the class scope, and that's the reason for it. Outside of the class scope, such as here, int main, right? And inside main, we'll say, okay, that's our main function, and we want to instantiate a point, and we call set, right? We say point dot set. This is how we call a member function. Pass couple of values like 4 and 88, whatever that is, right? So that's clearly again we can no longer say pt.x equals 4. No, that's not going to work, but we do it this way. So so that hopefully clarifies the fact that you know, that's what we say on the slide. Member functions can access any other members, including functions or data, whether private or public. Within the same class, everything is available. There is no way to isolate you know, this function isolated from the rest of the class. As long as they're all declared inside the class, they all can do the same thing. They can access the same data. They can, functions can call each other. It's all pretty straightforward. There's no way to isolate this function from the rest of the class, right? So this doesn't work. It works only here in elsewhere. When we begin to use point, then of course the access is exactly restricted to what is public and what is private. Next. Non-members can access only public members. That's fine. Overload resolution happens before access checking. Okay, so if there is a function So you know, it's like if there is a function set which the overload resolution. So for instance, I know I can try to make it private, I guess, right? So let's see what error we get. So I have a private function set, I have an instance of an object, and I have an attempt to call set. So when I build it, right? So I build this, see what kind of error we get. So what the compiler is going to tell us. I'm just wondering what exactly the error message is going to look like. So it says, cannot access private member declared in class point. So if I try to use some sort of a promotion so that, well, I mean, I guess I'm not going to waste any of my time. I think it perfectly makes sense to get an error that we get in terms of, you know, you cannot do this because now it's been made private. But just to know, sometimes it's helpful to know that overload resolution does happen before access checking. I guess I can demonstrate this. I can say there is a, you know, public version of set, which takes maybe takes set, so which maybe takes two double values. I don't understand why I can't type there. Double XX and double XX and double YY. So that's another possibility here. So I will take and define this function. I really don't care what it does. I'm just going to make sure that the compiler is happy. You know, define it and see what happens at this point. So there's a function that does nothing, that takes two doubles, and there's a main which wants to pass integers, right? So before we said, or maybe there will be a promotion, so the compiler will say, oh, there's a public function named double, and it should kind of promote 4 to 4.0 and 88 to 88.0 and try to promote. But let's see. So if we try to build this, it says cannot access private member declared in class point. So the promotion is not happening because there is an exact match for two integers, so no longer works. So the client must switch over to doubles, I guess, to make sure that the overloading resolution and access control here, what is private and what is public, is all in agreement.